in all these cases, barrier islands act as a bridge between mainland and island. As there are different types of barrier islands here, it becomes hoop if they are formed in such a way that they are parallel to the coast but not attached to the land. Then they are called offshore or longshore bar. After absorbing this radiation, Earth re-radiates in the form of long wave radiation. Hello friends, myself Ajay Raj Singh. I have been teaching geography for the past 17 years to UPSC aspirants, both geography optional and GS geography. So we were discussing the previous year's questions and we'll continue with that. Now the next question is, my new batch is beginning from 15th September, both for GS geography and geography optional. Those of you who are interested, they may join it. It is live online classes. So the next question is, examine the distribution and balance of energy in the Earth's atmosphere system. Distribution and balance of energy in the Earth's atmospheric system. Simple question, direct question, heat budget. हीट बजट को इन्होंने घुमा के लैंग्वेज ऐसी कर दी कि वो अलग लग रहा है. डिस्ट्रीब्यूशन एंड बैलेंस ऑफ एनर्जी इन द अर्थ्स एटमॉस्फेरिक बजट. It is simply heat budget. Earth's heat budget refers to the balance that exists between the incoming solar radiation and the outgoing terrestrial radiation. This balance is refers to Earth's heat budget. Since Earth behaves like a perfect black body, so there is complete balance between the incoming solar radiation and the terrestrial radiation radiated back by the Earth. There is complete balance. Therefore, the temperature of the Earth remains same. Now, to understand this heat budget, you need to understand this analogy. Suppose this is Earth's outer atmosphere. Earth's outer atmosphere. And this is Earth's surface. Suppose 100 units of solar energy is received at the Earth's outer limit. Then there are dust particles in the atmosphere. These dust particles are very important for the purpose of scattering. They scatter the incoming solar radiation, and by way of scattering by these dust particles, 6 units of incoming solar radiation is reflected back to space without playing any role in heating and cooling. Then there are clouds. Clouds happen to be very good reflector. 23 units of incoming solar radiation is reflected back by cloud without playing any role in heating and cooling. And the third is ice covered surfaces on the Earth. These ice covered surfaces also reflect back 7 units of incoming solar radiation back to space without playing any role in heating and cooling. Total 23, 7 plus 6, it is 36. 36 units of incoming solar radiation are reflected back to space without playing any role in heating and cooling. This is known as Earth's albedo, planetary albedo. Now, as the ice covered surfaces are melting, the planetary albedo is getting altered and more insolation is being absorbed by the Earth's surface. That is the cause of global warming. Now, 17 units of incoming solar radiation are absorbed by the atmospheric gases, especially oxygen and ozone, in the upper atmosphere, in the upper troposphere. They absorb short wave radiation, and carbon dioxide and water vapor in the lower part of troposphere, they absorb long wave radiation. Together, these gases absorb 17 units of incoming solar radiation. Now, what is left is 17 units plus 36 units. If you subtract from 100, left over is 47 units. These 47 units reach the Earth's surface, and these 47 units are absorbed by the Earth's surface. After absorbing this radiation, Earth re-radiates in the form of long wave radiation. And this long wave radiation radiated by the Earth, the atmospheric gases are much more comfortable with absorbing this terrestrial radiation because it is long wave radiation. And most of the atmospheric gases are comfortable in absorbing long wave radiation. Despite that, 8 units of terrestrial radiation manages to escape to space without being absorbed by the atmospheric gases. Now, as the Earth radiates, the clouds present in the atmosphere, they are very good reflector. These clouds reflect back the radiation back to earth. Earth again radiates back to atmosphere. The atmosphere again by way of clouds reflect back to earth. In this process, there is absorption of 14 units of long wave radiation by the atmosphere. This returning and giving, matlab, this process of exchange ultimately results in the absorption of 14 units of heat by the atmosphere. Then earth, 70% of the earth's surface is covered with water, where huge amount of convective activities takes place, evaporation takes place. As a result, water, after absorbing heat, it evaporates in the form of vapor, and later on when the vapor condenses, latent heat of condensation is released. 71% area is covered with water, huge amount of evaporation takes place, and when water transforms into vapor and move upward by way of convective activity, it carries that heat. And on condensation, when the vapor condenses into water, it releases that heat in the form of latent heat of condensation. This way, 23 units of terrestrial radiation is absorbed. Latent heat of condensation adds 23 units of heat to the atmosphere. And by way of conduction process, the air which is in contact with the surface, by way of conduction process, 2 units of heat is added to the atmosphere, the layer of atmosphere which is in contact with the surface. By way of conduction, 2 units of heat is added to the atmosphere, and this later by way of turbulence and convective mechanism is carried upward in the atmosphere. So total out of 47 units that reach the surface, all are radiated back. Only 8 units manage to escape to atmosphere. Remaining 2 plus 14 plus 23, that is 39 units, are absorbed by atmosphere. Now see, atmosphere receives only 17 units directly from the sun and 39 units of heat from the earth. That means atmosphere is heated more from below than from above, and that is the fundamental cause that in troposphere temperature decreases with height. Why does the temperature in general decreases with height in troposphere? Because this troposphere is heated more from below than from above. 39 units of heat it receives from Earth's surface and only 17 units from above in the form of incoming solar radiation. Now it is this 17 plus 39, that is total 56 units of heat that is trapped by the atmospheric gases, is responsible for running various bio, geochemical, oxygen, carbon cycle. All these cycles are run by this heat trapped in the atmosphere, and it is this heat that is responsible for existence of life on this planet. In the absence of these atmospheric gases, the earth would have experienced extremes of temperature. Now with the burning of fossil fuels, what we have done, we have increased the concentration of carbon dioxide or methane or nitrous oxide in the atmosphere. We have increased the concentration of greenhouse gases in the atmosphere. As a result, the heat trapping potential has increased. This 8 units which is lost to space, this percentage has declined because of more greenhouse gases, more heat is being trapped, and therefore the earth is facing global warming. Although ultimately this 56 unit, that is 17 plus 39, is also released back to atmosphere. 56 plus 8, that is 64, and this 36. Total amount of heat received by the atmosphere, earth and its atmosphere, is exactly equal to heat being released to the space. But in process, the atmospheric gases, the increased concentration of atmospheric gases leads to increased absorption of heat, and that is the basic cause of global warming. Pehle basically greenhouse gases were naturally produced. Now man-made activities have increased their concentration. As a result, the heat trapping potential of atmosphere has increased. Although ultimately this is also released, but while it is trapped in the atmosphere, this causes global warming because this proportion of heat trapping has increased. So it was a simple question. Now next question. यही करना था तुमको एग्जाम में, यही बना के आना था. Describe the process of formation of barrier island. Simple. These are formed by sea waves. They are the work of erosion and depositional activities performed by the sea waves. Describe the process of formation of barrier island and explain their significance. And what is their significance? Now, the process of formation of barrier island. Process of formation of barrier island and their significance. Suppose this is coast, this is sea. Features like barrier islands are formed when sea waves impact the coast obliquely, that is at an angle. When the sea waves, direct hit nahi, when the sea waves impact the coast obliquely, or obliquely बनाऊं, when sea waves impact the coast obliquely at an angle. In this case, when they strike the coast obliquely, they create long shore drift. In this impact, they carry the sediment towards the coast by way of swash current or uprush current, swash or uprush or surf current. They carry the sediment towards the coast, and by way of backwash, the sediment is again carried towards the sea. Again by way of swash, it is carried towards the coast. Again by way of backwash, it is carried towards the sea. In this process, the sediments get deposited parallel to the coast. Sediments get deposited parallel to the coast. Barrier islands are those islands which are the result of erosion and deposition performed by the waves, and these islands are found to be existing mostly parallel to the coast. So when the sea waves impact the coast obliquely, the sediment gets deposited. So the sediment gets deposited parallel to the coast. When they strike the coast obliquely, the sediment get deposited parallel to the coast. Now, initially, the sediment lies below the sea level. It is in the form of shoals. But continuous deposition of sediment by sea waves on the shoals, ultimately it emerges above the sea. When it emerges above the sea, it is known as barrier island. So when sea waves impact the coast obliquely, the sediments of barrier island, the sediments get deposited parallel to the coast by way of this mechanism that you have to depict in exam. The formation of barrier islands begins with the development of shoals. Subsequently, the shoals grow in height and emerge above the sea level to form barrier islands. एक standard definition तो barrier island की है, the barrier islands are in the form of ridges or mounds of sand that lie parallel to the coastline. But these are of various types. If these barrier islands are formed in such a way that they are parallel to the coast and they are not attached to the coast, they are away from the coast, such barrier islands are known as longshore bar or offshore bar. Those barrier islands, if they are formed in such a way that they are parallel to the coast but not attached to the land, then they are called offshore or longshore bar. If the barrier island is in such a way that its one end is attached to the coast and one end is open, one end is attached to the coast, this is coast, one end is attached to the coast and one end is open into the sea, then these barrier islands are known as spits. If the sandbar are formed in such a way that the one end is attached to the coast and the other end projects towards the sea, they are known as spits. In India, these spits have led to the formation of lagoons. See the case of Chilka Lake. If you see Chilka Lake, basically it is a spit which is attached to its one end. This Chilka Lake spit is attached to one end, and towards other end there is a narrow outlet through which Chilka Lake connects with the open sea. It is a spit whose one end is attached to the coast and one end is open into the sea. The other end is not connected. Chilka Lake. Or you can see the case of Pulicat Lake. In Pulicat Lake also, basically you can see this spit separates the Pulicat Lake from the sea. Same in case of Vembanad Island. Vembanad, within the Vembanad Lake, Wellington and Vallarpadam are the two islands, and here there is a spit known as Weapon Island, which separates it from the sea. So spits are responsible for the formation of lagoons. They lead to the formation of lagoons like Chilka Lake, Pulicat Lake, Vembanad Lake. In fact, Rameshwaram, if you see the case of Tamil Nadu, there's a spit. Rameshwaram is located on a spit. Rameshwaram spit projecting toward the sea from Tamil Nadu is very important, which has even attracted settlement. Usually, barrier islands are not fixed. They keep on shifting under the impact of storm waves. But this Rameshwaram spit projecting towards the sea has become so stable that it bears human settlement. At times, this spit, under the impact of storm waves and sea waves, gets curved, becomes curved. In that case, this spit is known as hook. ये different types of barrier islands ही हैं. It becomes hook, and at times it gets attached to the mainland. Then it is known as loop, and it encloses seawater and forms lagoon. This is another way of forming lagoon. एक तो वो था, when the spit is straight, then also it forms lagoon, and if it becomes curved under the impact of sea waves, high storm energy waves very often modify the shape of the spit by bending it towards the coast. So they assume the shape of hook. If they are not hook, or if they completely get connected to the mainland again, then it is known as loop, and they lead to the formation of lagoon. At times, these barrier islands are in such a way that they connect. ये see, this is land, this is sea. Barrier islands are in such a way that they connect two headlands. In this case, they are known as connecting bar. Barrier islands, if they connect two headlands, they are known as connecting bars. At times, these barrier islands connect coast with an island. In this case, they are known as tumbolo. A tumbolo is formed when the connecting bar connects mainland with an island. Tumbolo acts as a bridge. In this case, basic connecting bar या तो दो headland को connect कर रहे हो, or if the barrier islands are connecting two islands, then it is known as dumble. Then also they act as a bridge for movement between two islands. And if the barrier islands, these connect mainland with an two mainlands or mainland with an island, in that case it is known as connecting bar. Connecting bars are formed when these barriers join two headlands or two islands. Two headlands or two islands. In this case, they are known as connecting bars. But if they connect a mainland with an island, in that case, it is known as tumbolo. Here, in all these cases, barrier islands act as a bridge between mainland and island, as a bridge between two islands, as a bridge between two connecting bars. So connecting bars are formed when the barrier either join two headlands or two islands. This connecting bar, and they are known as tumbolo when the barrier islands connect one mainland with one island. A tumbolo is formed when the connecting bar connects mainland with an island. Thus, tumbolo or connecting bars always act as a bridge between coast, between two headlands, or between two islands. In case of tumbolo, a very good example is Ratnagiri and Malvan Island. Ratnagiri is in the western coast of Maharashtra, and Malvan Island is in the sea. So with this, we have finished the discussion of physical geography part of 2025 question paper. Now we will begin with the human geography part of 2025 question paper. That is that second part.